What I will discuss today is that particular topic in techniques of integration, which we call as trigonometric integrals. In trigonometric integrals, we divide this into different cases. First is the case where we find the integral of sine to the n of x dx, okay, or integral of cosine to the n of x dx, where n is either even or odd. But of course, the integral of the form cosine to the n of x sine to the m of x dx, where n and m could either be both odd or both even, or one of them is odd. We will consider the case first where this n here is odd, or whenever we have this form, either n or m is an odd integer. Okay. So let's start with a particular example. Suppose you're asked to evaluate the integral of sine to the 5 of x dx. The same thing can be said about cosine. So we'll just consider the example where we have sine. But you can use this also as a pattern if you have integral of cosine raised to an odd exponent. Okay, whenever you have this form, first thing you do is, of course, by the way, you can solve this by using reduction formula. Formula that was derived by using integration by parts. But reduction formula is not an easy method, especially if your exponent here is large. So the most practical method to use is the trigonometric integral, and this is what we're going to do. First, we will try to separate a factor of sine to the 5 of x, okay, so that we have integral of sine to the 4th x times sine x dx. The purpose actually of separating this is that we want to write this in the form of integral of u to the n du. So basically this will serve as your du. But if this is your du, the u must be cosine because this is sine, right? So how do we convert this into the form of sine, of cosine? Well, you can write sine to the 4th of x as sine squared of x squared sine x dx. And then we'll make use of the familiar identity from trigonometry that says cosine squared x plus sine squared x is equal to 1, right? If you remember that, okay, particular identity. And from this identity, we can express sine squared x in terms of 1 and cosine squared x. So therefore, this expression can be written now as sine squared x. So you have 1 minus cosine squared x, then squared, then sine x dx. And then let's expand this. So this can be written as 1 minus 2 cosine squared x plus cosine to the fourth of x times sine x dx. And you can write this expression now as integral of, distributing this, you have sine x dx minus 2 integral of cosine squared x sine x dx plus integral of cosine to the fourth of x sine of x dx. So we know the integral of sine to be negative. Cosine of x, we have negative 2. Now this is actually of the form u to the n d, where your u is cosine x and your du is sine x dx. So that means that the integral of this is cosine cube of x over 3, right? Do you follow? U squared du, okay, plus this one also is in the form of u to the n du. You have u to the fourth du, where your u is cosine x and du is sine x dx. Therefore the integral of that is cosine to the 5 of x over 5, then plus c. So that's it. We have the integral for sine to the 5 over x, sine to the 5 of x dx. And just write this in the form where you have 2/3 here and 1/5 here. Okay. Next problem here is for example number 2. Let's consider the case where we have the form integral of cosine to the n of x sine to the m of x dx, where one of n or m is odd, or n and m could both be odd. Okay, so let's try another example. I think let's write sine to the 5 of x and cosine maybe to the 4 of x dx. The same principle actually is used here. What we do is for that trigonometric function where the exponent is odd, you separate one of the factors of that. So that means that you can write that as sine to the fourth of x, then cosine to the fourth of x, then we have the sine of x dx. You are actually reserving here the du for the integral of u to the n du. But what to do with this one? This needs to be converted to cosine, and to do that we use again the identity we have a while ago. So this can be written as 1 minus cosine squared x, then squared, because this is to the fourth, right? Okay, this is your sine squared. Then you have cosine to the fourth of x, then sine x dx, and this is equal to, expanding this, we have 1 minus 2 cosine squared x plus cosine to the fourth x, and cosine to the fourth x, then sine of x dx. Okay, and this is equal to, okay, this is equal to integral of cosine to the fourth of x sine of x dx, okay, for 1 times this one here, then minus 2 integral of cosine, so cosine squared x times this is cosine to the 6x sine x dx plus integral of cosine to the 8 of x sine x dx. And so this is now in the form of integral of u to the n du, so therefore this is 1/5 of cosine to the 5 of x minus 2 over 7 sine to 7 of x, then plus this one is 1 over 9 cosine to the 9 of x, then plus c. Okay, so we have the integral of sine to the integral of sine to the 5 of x cosine to the 4 of x dx, which is equal to this. Okay.